So what's a linear relation? It's a line. It's an equation of a line. Do you guys remember an equation of a line? What would it be? Y equals mx plus b. And m represents what? Slope. And b represents y-intercept. Now, this would be if we're talking about the format, which is y equals mx plus b, which is the slope y-intercept form. Okay? There's two forms that we talk about in straight lines, and one would be the standard form. So it's going to be x plus by plus c equals 0. So this is called the standard format. We don't use this too often. It's not very helpful, where a, b, and c are numbers, by the way. Okay? A, b, and c, they're going to be numbers. And straight line. Most of the time, we see a linear equation is written like this. How do you know that this is a linear equation? What tells you that it's a linear equation? You have the y-intercept and the slope, but what tells you that it's a linear equation is because it's degree 1. What's the exponent on x? Do you have any exponent on x? That means it's exponent 1. Okay? This is how we know it's linear. Linear means degree 1. Would this be a linear function? No, because what's the highest degree that you have here? 2. So this is not linear. This is linear because the degree on the x is 1. Okay? This is how I know it's linear. Now what if the function was written like this? 2x minus y plus 5 equals 0. Does this still represent a linear equation? Yes, it does. Because on the x, that's a degree 1. Okay? So you're always looking at the x, and you're looking that the x is a degree 1. And obviously, the y has to be degree 1 as well. Okay? So we're looking that both x and y have a degree 1. Okay? This is how we know it's a linear function. Now, here's a line. So this is my x and y. Sorry, that's a y. These are your x and y axis, right? And then if I'm going to draw a line, that's a straight line, yes? You guys agree that this is a straight line? Okay. It intersects the x-axis. Do you see that it's intersecting the x-axis? So this is your x-axis, right? It's intersecting the x-axis right here. Yes? It's passing through the x-axis. Okay? Is it passing through the y-axis? Yes, right here. Right? These 2 points, this is called the x-intercept. And this point is called the y-intercept. Okay? So a straight line, unless it's a horizontal or a vertical line, it's going to pass the x and y axis. So the x and y intercept of a linear relation are where the line crosses the x-axis and the y-axis respectively. So we call them the x-intercept and the y-intercept. Now, how many of you, with show of hand, remember how to place points on the Cartesian plane? So if I give you point 2, 3, you know where to put it here. couple, 3 maybe, 4. Let's do a test here. So this is your x-axis. What do we call this point? What do we call this point? That's a 0 point called the origin. Okay, so this is where your 0 is. And then to the right of it, I will have positive. So 1, 2, 3, 4, 5, 6, right? Does this ring a bell now? What goes to the left? The negative. -1, -2, -3, -4, and so on, right? Now, these are the x values because they are on the x-axis. How about the y values? Where would they be? So, this is going to be 1, 2, 3, but these are the y values. Remember that. 4, so on and so forth. And then below is going to be your -1, -2, -3, -4. If I give you a point is going to be, it's going to look like this with a value first and a second value. The first value represents the x, the second value represents the y, always in a point. Okay? So if I give you 0.24, where would you go? 2 on the x, right? So 2 on the x is right here, and I have to go up 4. So that's all the way to the 4, and this is where I would place my point. Okay? I'm going to call this point A. Do we remember that? Okay? So 2 on the x, 4 on the y, and this is where my point is. How about if my point is -5, 3? So on the x, I have to go to -5, and then up to the 3. Is that where my point is? How about if I give you this point? Where is it going to be? -3 where? I have too many -3s. Right on the y. Because it's going to be at the 0, right? The x is 0, and then you're going to go down to the -3. So your point is going to be right here. Right? How about if I give you this? So it's going to be at 6 right here, and that's called letter D, right? So placing the points on the Cartesian plane, we call this a Cartesian plane or the x and y plane, right? Has to be x, y. Are we okay with this? Now, we said that when our graph passes the x-axis, we call that the x-intercept. Okay? So out of these points, which point would be on the x-axis? Which point is on the x-axis? D. D is on the x-axis, right? D is on the x-axis. Now, we call that the x-intercept. Okay? How about C? What do we call that? The y-intercept, because it's on the y-axis. Okay? This is just a quick review of points on the Cartesian plane, because I'm going to get you to another whole thing. Now, My question to you, if you're looking at the x-intercept, right? If I give you another point, let's see this point here. I'm going to go here. What would be the coordinate for this point? What's the x value? -2, 0. This is also on the x-axis, no? It's on the x-axis. What's common between these 2 points that are on the x-axis? Which value? Which value? The y value. The y value, right? So the y value is 0 for both of them. So for your point to be on the x-axis, your y value is going to be 0. Right? Because you're not going to move. You're going to stay on the x. Okay? Now, if I give you another point here, what would be this point? 0, 5. And this point is located on which axis? On the y-axis. So it's the same as this, no? Okay. What's common between these 2 points that are on the y-axis? The x value is 0. So if you're on the x-axis, then the y value is 0. If you're on the y-axis, then the x value is 0. You're going to use this even when you're doing quadratic, when you're doing exponential, when you're doing any type of graph we do in math. This information right here is true for any function. Okay? Even like when you go to grade 12 and you do sinusoidal. Okay? Or you do the sine and cosine. Same thing. Now, I'm gonna go back to my lesson. Okay? So, to find the x-intercept, what do? What should be equal to 0? The y. So set y equal to 0. And solve for x, giving the coordinate point, it's going to be x, comma, 0. To solve for the y-intercept, what do you set equal to 0? X. And solve for y, given coordinate 0, 1. To draw the linear relation, plot the x and y intercept. So you're going to just find them on the Cartesian plane and draw a line or a straight line between the 2 points. So let's look at an example. So you're going to graph this line, but the question is asking you to graph it using the intercepts. Okay? So I need to find my x-intercept and I need to find my y-intercept. Okay? To find the x-intercept, what do? y0. So to find the x-intercept, can you guys tell me your function? Yes, because both the x and the y has a degree 1. Okay, so to find the x-intercept, I'm going to set y equal to 0. So y is 0. So I'll have 2x plus 0 minus 6 equal to 0. Are we okay with this? Do you understand what happened here? So I replaced y with 0. So now I only have x in my equation as a letter. So let's simplify this. That's 2x minus 6 equals 0. Now, how do I solve for x? How do you isolate for x? Move the next negative 6 over. It becomes 6. Then divide by 2 because there's a multiplication here. The opposite of multiplication is division. So if I divide by 2, I will get rid of that and I get x equals 3. Okay, so what we're doing here, we're solving for x by doing isolation. Does anyone not know how to do isolation? So, what's my x-intercept? 3, 0. Where would that be right here on the Cartesian plane? Right here?
Yes.
So I found the x-intercept. What else do I need to find? Y-intercept. To find the y-intercept, what do I do? Yeah. So to find the you have to set x equals to 0. So in this case, it's going to be 2 times 0 plus y minus 6. You guys agree with this? So if I scroll back up, instead of x, I'm replacing that with a 0. Okay? So it's 2 times 0 plus y minus 6. What's 2 times 0? 0. So that's going to be 0. So I'm with y minus 6 equals 0. So y equals 6. Something that you guys should be aware of, that when you're isolating for the letter, you're moving everything away from it. You're doing what we call the opposite operation. So if it's a subtraction, it becomes an addition. If it's an addition, it becomes a subtraction. Multiplication is division. Division, multiplication. So what's my y-intercept? 0, 6. So 0, 6, where would it be? So you see I have 2 points. All what it takes right now is to draw a straight line between the 2 points. Okay? So all what I have to do right now is take my ruler and draw a straight line that goes through the 2 points, extend it a little bit because the line is continuous. It's going to keep going, right? And that would give you your line. So I just graphed my straight line, finding 2 points, the x-intercept and the y-intercept. If it's multiplication, because you're multiplying 2 times x, to get rid of that 2, you have to divide by it. Because what's the opposite of multiplication? Division. Okay? Okay, so here's what I want you guys to do. If you go to your